Okay, so this is the adder subtractor lab. So in order to make this work, we need the half adder, the full adder, and the ripple carry for files from last lab in order to make all this work. So here we're starting off with the AdderSub8 module. So you have C input, so you have C input, and input A, input B, with and input A and input B with a bus from 7 to 0, and an output of S with another bus from 7 to 0. And now you have an output C out and a wire C out 3. So now this one connects to the adder, it connects to ripple carry 4. So here we're having ripple carry 4 is 0. So the C in A, the bus, this one is from 3 to 0. Same with B, same with input B, and output S. And then we're connecting it to C out 3. And then similar here, we're doing ripple carry 4 1, and we're connecting the C out 3 wire, to the input of A, B, and B from 7 to 4. Sorry, from 4 to 7. And then same thing with the output S. And then we're connected to the output of C out. Now here we have something similar. So we have 3 inputs, B in, A, B. The same thing with the buses from 0 to 7. And then we have an output also with the bus of 0 to 7. And another output B out. And now here we have a wire with a bus of 0 to 7 named E. And all of these are going to be E, B, and B in going to be connected to XOR gates. They're going to be connected to 8 of them. And now here we're including the AdderSub8 file, and we're connecting it to there. We're connecting the B in, the A input, E itself, not just the different output, and B out. So here's what the schematic would look like. It's a pretty big one. So you see here, B in, A, and B are all connected to these these 8 XOR gates. And so where you see A here is being connected to AdderSub8. And so if we open this up, you see the 2 ripple carriers in here. You see A is being connected to the inputs of both of these. And so same thing with B as well. And so I'll open this up. And then you have the full adder. These are connected to the full adder. See, it's connected to A with the bus of 30 and 0. It's connected to the A and full adder. Same thing with B. And now you have the half adder. You have the input from the full adder being connected to the half adder. It should look like this: an AND gate and an XOR gate, which is basically the same exact thing from last lab. And all of this is being connected to the outputs of B out and diff. So this test bench would have two regulators. A with regulators add 0 sub 1 and regulators with A and B 7 with the bus of 7 and 0. Two wires. This one is sum with a bus of 7 and 0 and difference. And then you have this other wire with connecting to carry and borrow. So here we're including the AdderSub8 and Subtractor8 files, and we're connecting the add 0 sub 1, the A, B, sum, and the carry to AdderA. And then here we're doing something similar, except we're connecting difference and borrow. So this is the for loop. And then you have all the displays. And so that timing diagram would look like this.